In this video tutorial, I'm going to walk you through all the different features that you have on your TI-84 Plus CE graphing calculator that I personally think are really useful. So we're going to break this up into two parts. Everything above this line down here consists of things that are just part of your graphing calculator that I think you may or may not be super familiar with, but it's really important that you are. So we're going to walk through those ones, and then below the line are going to be the 23 programs, and we're going to go through those in great detail. So the assumption here is that you already have the programs on your graphing calculator. So when you press program, make sure, in my case, I have the Python version showing here. Normally you wouldn't have this first option, but once you press enter in this scenario, you should see all your programs. If not, make sure you go to day 5 of week 1, step 3, and go ahead through that process where I walk you through how to transfer all the programs. Everything we're going to be doing is from this reference document, which is from pages 36 and 37 in your folder. So let's go ahead and start with everything above this line. More specifically, above this line here are 4 functions that have to do with fractions and decimals. So when you press these two buttons, alpha y equals, so alpha followed by y equals, you'll get a menu of these 4 options. We're going to start with the first option. You could press 1 or you could press enter, and it creates a horizontal fraction bar. It's pretty useful because then you don't have to use parentheses in different contexts if you were doing it more as like a sideways fraction bar. So let's type it in, 17, and then I'm going to go ahead and use the right arrow key. So I'm a big proponent of making things as consistent as possible. So even though down would also work in this scenario, eventually if I wanted to type the fraction, then put like minus or plus something else, I'd have to progress to the right anyway. So I'm going to go ahead and get used to just pressing right to do the denominator, because then I could press right and continue with the problem if needed. However, once I've typed it in, I have a horizontal fraction bar, which is pretty great. Now let's go ahead and actually combine that with the second feature. So let's say if I go right, and maybe I wanted to add a mixed number. So in order to type in a mixed number, we're going to press alpha y equals again, and then it's option number 2. Notice that u that's in front, that has to do with the whole number, and then the n over d is the fraction component for that mixed number. So let's choose number 2, either by scrolling down and pressing enter, or just pressing the number 2. So if I want to type 5 2/3, for example, I'll press 5 right, 2 right, 3. And then at that point, I don't have to go right anymore. I could just press enter, and then it'll give me the value. Now notice it gave me the answer as an improper fraction. If I want to turn an improper fraction to a mixed number or vice versa, that's where we get to the third function here. So let's go to alpha y equals, and notice functions 3 and 4 all have to do with changing from one type of thing to another. In the case of option number 3, it's from an improper fraction to a mixed number or vice versa. And then we'll get to option 4 in a moment. But let's go ahead and choose option 3 for now, and then we'll press enter, and it took that improper fraction and turned it into a mixed number. Now if I press enter again, it goes back to an improper, and back and forth, back and forth. So don't get in that loop while you're taking the test. That would take a lot of time. But just so you know, it goes back and forth. Now let's go to the fourth option. So if instead I want to take that mixed number, fraction, whatever kind of fraction I have, and turn it into a decimal, or if I have a decimal and I want to turn it into a fraction, I would choose alpha y equals, option number 4, enter, and it turned it into a decimal. If I press enter again, back to a fraction, more specifically improper, and it goes back and forth. All right, on to this function in between these two lines here. This is how to store a value as x. So first, let's talk about the use case here. So if you're given a function, for example, this one here, and they're saying find the value when x is -2. In other words, plug in -2. So especially with negatives, we often need to use parentheses to make sure we don't make an error. Well, the store function makes it so that we don't have to worry about that at all. So let's go ahead and type in -2. Really important that you use this sign as the negative, not the minus sign, otherwise you'll get an error. So we'll put -2, and then here's the store key right above on, and then we're going to choose this variable key here. Even though it has 4 different variables, when you press it, it'll say x. And then we'll just go ahead and press enter. And then now what we've done is made it so the graphing calculator, whenever we type x, it's going to think -2. So I can go ahead and type this function exactly the way that I see it. -2, we have x squared. Here's the squared exponent. If instead you were doing a different exponent, you do the caret, and then like to the 3rd power, 4th power, whatever it might be. We'll go ahead and do minus. Now you could do the normal minus sign. 5x plus 7. And then when we press enter, it found the function value for when x was -2. Now the common question I get all the time is, how do I make it go back? Well, there is no back. x was never something to begin with. If, for example, you go to y equals and you type in whatever function, it's still going to graph it accordingly. It's not going to be messed up because it thinks x is -2. So the only time you would need to change it is when you're utilizing it in this specific scenario. In the home screen, you would just change it to something else. For example, 5 store x, and then enter, and then now it's 5. In other words, storing the value as x will in no way affect your graphs. All right, on to the programs. So here I'm going to go ahead and point out some general rules of thumb. So first off, to get out of any program, we're going to go ahead and press second mode, which actually activates quit. So let's give an example. If I'm in this first program here and I decide, oh, I don't want to be in there. If I just press second mode, it quits it, and then I'm out of it. And then I can press clear and then just be done with it. However, to get out of programs that have an initial menu with multiple parts, and we have 6 of them, for example, completing the square, function, midpoint, Pythag, radians, and shapes, we're actually going to have to press 2 different buttons to get out. So let me show you the example here. Let's say we go into completing the square. We'll go into that program, and if we decide, oh, I don't want to be in there, well, notice I have this kind of loading key here. If I press quit, it doesn't do anything. If I press second mode, also doesn't do anything. So I don't want you to panic in those programs that have this kind of initial menu with options. So all you're going to do is press on and then enter, and then you're out of it. So let's go ahead and start with the first program, Factor. So when you go into your programs, you could choose number 1, or you could just press enter. You can press enter again. Whenever you get into the program, you always press enter on that home screen. And what this does is it factors a quadratic expression. So an expression is one that doesn't have it equal to a value. If it's equal to something, then you're going to solve, and that would instead be program number 2, which we'll get to in a moment. But let's say I have a quadratic function and I want to factor it. I'm going to go ahead and type in the coefficients. So I have 6, enter, -1. Remember, it's really important that you use this negative key, and then we'll do the same thing, -12. And it gives us the function in factored form. Yeah, it's pretty powerful. Now, obviously, the order doesn't matter. They could have put 2x minus 3 first, and then 3x plus 4, because multiplication is commutative. On to program number 2. So for the second program, it's Quad Solver. So it helps us to solve quadratic functions instead of just factoring it. So let's go to program number 2, and notice it has to be in standard form with everything equal to 0. So with an equation, we're able to now solve it, but it has to be equal to 0. So we're going to move this 15 to the other side, which means you have a +6 for A, a +1 for B, but a -15 for C, so that it's all equal to 0. And it gives us our 2 solutions in either order. On to program number 3, slope int. So program number 3 here is slope intercept. We'll press enter, and it helps us to find the slope and the y-intercept for the line when given 2 points. So let's go ahead and use this example that I have here. We'll go ahead and put 8 and -1, as well as -6, -8. And then we have the slope and y-intercept. If you had to put it in slope-intercept form, we know that's y equals mx plus b. We could just put y equals 1/2 x minus 5. Program number 4. So in the 4th program, you could scroll down, or you could just type 4. It's called Solve Systems. So it helps us to solve a system of equations. Now notice, form is very important. So you pay attention to however it's documented in the program. In this case, it's saying they need to be in standard form. And the example I have here, they're already in standard form. But if they weren't, you would need to arrange them accordingly, just like we did for Quad Solver. So let's go ahead and type in all these coefficients. So that was for the top equation, and we'll do the same thing for the bottom equation. And we get that the point of intersection for these 2 lines is -1, 2. On to program number 5. So the 5th program is Solver. So this program solves a linear equation when it's just one unknown. So Solve Systems was for 2 equations, 2 unknowns. Solver, 1 equation, 1 unknown. And notice the x's, because they don't have a written exponent, are assumed to be to the first power. If instead any of the x's were to the second power, it'd be a quadratic function, and we'd use Quad Solver. So a very important distinction there. So let's look at Solver, and the nice thing about this one is you don't have to rearrange anything. They're saying just type in the entire left side, which we'll go ahead and do this example just as is. So we type in the left side, we press enter, we go ahead and type in the right side, press enter again, and it finds the solution for us. On to program number 6. So program number 6 is Absolute Solver. So we'll press 6, enter, and on this window you see this loading icon, so we're going to press enter in just a moment, but notice we assume that a is greater than 0. So the number in front of the absolute value has to be positive. So notice in our example here, it's a +5, so that's great. If it were negative, you'd have to divide the negative to the other side, otherwise it won't work. So we'll go ahead and press enter. And then you have various options here. For our use case, we're going to consistently do it when the absolute value is equal to something. But it's good to know that if ever you have a use case for an inequality scenario or finding restricted values, what can it not be equal to? You could use those as well. But we're going to go ahead and just press 1, and then we're going to type in all these values accordingly. So notice A is the value in front of the absolute value, which is 5. B is the value in front of X, which is 2. C is the value after X, which in our case is -3. And then this is really important. Notice it says plus D, but we don't have anything after the absolute value. So in our case, it's 0. But if you had something there, you'd input it accordingly. And then the value on the right side of the equal sign is 10. So it gives us our two solutions. So the 7th program is called arc. And what it does is it finds the arc length when we know the radius and the measure of the arc. So we'll go ahead and put in, for this example, 5 for the radius, 30 degrees for the measure of the arc, and we get the answer. Now what's really important is to notice it's showing the arc length as a pi, where a is 5/6. So that means that the actual arc length is 5 pi over 6. They just don't put the pi in the answer. It's assumed to be next to the constant. On to program number 8. So the 8th program is called arithmetic sequence. It's a pretty cool program, but honestly the use case isn't that great. So you may or may not ever see it, but let me go ahead and show it to you. So let's go to this program here. And what it does is it finds the nth term and the sum of the first n terms for an arithmetic sequence. And an arithmetic sequence is essentially just a linear function. So notice it's consistently increasing by 5, and they're saying find the 35th term and the sum of the first 35 terms. So what we would need to input is the first term, which is 2, and then also the difference, which is a synonym for the slope. So we're going to input 5, and if we want to find out the 35th term and the sum of the first 35, we're going to put 35 there. And it says the 35th term, if we kept increasing by 5 for 35 terms, would be 172. And if you add up all of those terms up to and including the 35th, you'll get 3045. So pretty cool, but again, not so sure if it'll come up or not for you. Now let's go on to program number 9. So this 9th program is called Circles, and it just is one of the programs that's informational. It's not actually functional. So we have a handful of those ones. So let me point it out here. It gives you the area, circumference for a circle. It also gives you the standard equation of a circle. Notice this is very important. The center is HK. Notice in the equation it has -h, -k. So if you are trying to find the center, you have to take the opposite of each of the values there. If instead you're already with the center value and you're putting it into the equation, same thing. You have to do opposite of each of those values. We also have the arc length and the area of a sector. The nice thing is we have a program for finding the arc length, so you don't necessarily need it. Same thing, we're going to see a program for the area of the sector, but it's good to know the formula anyway. Now, if instead you have a TI-84 Plus instead of a CE, I want you to notice for a couple of things. One, because the font is so large in the TI-84 Plus, it almost feels like you're really zoomed in. Notice you can't even see the circles program. In the TI-84 Plus CE, we were able to see the first 9 programs. So we're going to go ahead and scroll down to circles. And the other thing I want you to notice is you can't even see all the formulas, right? It's like so zoomed in. So that's one of the negative sides of having a TI-84 Plus. Hopefully you have a CE. It just makes it a little bit easier and the interface is just way more user-friendly. All right, on to program number 10. So program number 10 is also referred to as program number 0 if you look here. So we could type in 0 if we want. After that, they're no longer numbered for us, but we'll go ahead and type in 0, and it's called Completing the Square. This is the first program of 6 in total where it has a menu of multiple features here. So the way you'll know that it has multiple features on this document is I have this blue bracket, which I have for each of those 6 programs. And also you'll see that I have a note in the upper right corner next to each program where it says to get out of this program, press on and then enter. So very important to remember. So for example, if I want to get out of this program because I decided I didn't want to be in it, we just press on and then we press enter and then we're out. But we want to be in the program, so let's go back to it. So in Completing the Square, there's 2 different programs. The first one is if you have a quadratic function and you want to take it from standard form to vertex form. So let's go ahead and try that one. So if we have, for example, 5x squared plus 40x plus 77. It gives us the function in vertex form. So pretty cool here. So that means the function would be 5 times the quantity x. And then notice what they gave you is really great. This is the vertex. So if they ask for the vertex, it's -4, -3. That is your HK, the vertex. However, if you need to put it into the equation, because that's the final answer, let's say, is the equation, not just the vertex, because the h has a minus in front of it, whereas the k does not, the h value has to be flipped when inputted into the equation. So it becomes a +4 because it was negative. If it was already positive, it'd become negative. Whereas the k value, because it's just a plus, whatever it is, stays that value. If it was negative, it's still negative. Positive would stay positive. So hopefully that makes sense. It's very important to contrast that now with instead the equation of a circle. So let's do that. Let's continue with completing the square, but we're going to go to option 2, circle. So if you have it in this standard form, which I want you to notice the difference between the TI-84 Plus CE and the TI-84 Plus. So here in the TI-84 Plus, you can't even see the full format. So it's kind of unfortunate. But getting back to the TI-84 Plus CE, we can see everything that we need here. It needs to be all equal to 0, which we have it in this form. So let's go ahead and input these coefficients, and you'll see exactly what this program does. So I'm going to type them all in, and we get the standard equation of the circle. So if they asked for the center, it's 3, -4. That's great. If they ask for the radius, notice this is the radius squared. So you would take the square root. In other words, it'd be 6 in this case. Now, if they want the equation of the circle, notice both the h and the k have minuses in front of them. That means you have to input the opposite. So for example, it'd be x -3 and y +4. And I have that down here. So that's an important little detail. So when it was in vertex form, it was just the opposite of the h value when inputting it in there, whereas the k was as is. For a circle, it's opposite for both. However, the values they give you are actually the vertex. So if they ask for the vertex, you don't flip it, it's -4 to -3. If they ask for the center, you don't flip it, it's 3, -4. It's just when inputting into the equation, you flip just the h for the vertex one, whereas you flip both the h and the k for the circle one. On to program number 11. So starting with distance, this is the first program where you'd have to scroll down to get to it. Something that's good to know, and you may or may not decide to do this, but if you know you're going to use the program distance, and you know that you're probably going to have to scroll down a bit, the other thing you could do is notice that above each key, there's a green letter. To activate those letters, you have to press alpha. And notice it goes in alphabetical order. You have A, B, C, D, E, F, G, and it keeps going there, right? So if I know I want to go to distance, once I've gone into my program menu, I can press alpha, and then notice this key here has a D in the upper right, and then it goes right to distance. So that could be a good thing to know to shorten the time it takes to just keep scrolling down, but you could always scroll down. If, however, you know you want a program that's, watch, I'm going to press up. If you know you want like the T's, which are on the very bottom, you could wrap around by just pressing up. All right, but let's go ahead and do what I was saying. We'll go to distance, we'll press enter, and this finds the distance between two ordered pairs. So let's say I have 2, -1, and -6, 0. It found the distance. It gives it to you as an exact root and a decimal rounded to the hundredths place. Now we're on to program number 12, function. So this is one that is just informational. So let's go ahead and check it out. Now, what you could do, so you could get right to the f's by pressing alpha, and then notice f is above cosine, and then we'll press enter and go into it. It has 3 functions here, and just as always, for these particular programs, and as I mentioned before, for the 6 particular programs like this one that has a menu of multiple options, if you decide you need to get out of it, you need to press on and then enter. You wouldn't be able to press second in mode. So just keep that in mind. Now let's look at each one by one. The first one just gives you the 3 forms of a linear equation. So you have slope intercept, standard, and point slope. The second one gives you the 3 forms of a quadratic function, vertex, standard, and intercept form. And then finally, the third one here gives you the standard form of an exponential function, tells you what the a value represents. It's the y-intercept. B is the common ratio, the difference between whether it's growth or decay based on the b value, and then the real-life models for growth and decay. On to program number 13. So this program, inequality, we could scroll down or we could just press alpha, and then the I is right above x squared. We'll press enter. And what's really great about this program is it naturally does the step that a lot of people make a mistake on. So with inequalities, if you multiply or divide by a negative, it flips the inequality symbol, but the program does it naturally. So let's go ahead and type in this particular inequality. So we have -2, and we'll just type everything as is. Now you might be wondering, well, how do you type in the inequality symbol? Good question. You're going to press second and then math, and it gives you all these different operations. Since we're choosing greater than or equal to, we'll choose option 4, and then we'll press 12, and then when we press enter, it solves it for you. So x is less than or equal to, they give you the decimal value, but also the fraction equivalent. So x is less than or equal to 1/6. On to program number 14. So midpoint is another one of those that has multiple features to it. So let's press alpha, we'll get right to the m's by pressing divide, press enter, and then when we go into it, it depends on what we're looking for. If we're trying to find the midpoint, we'll choose that first option. So if we know the two endpoints, you just input them really in either order, doesn't make a difference. So I'll put this ordered pair first if I want, and now I'm gonna put this other ordered pair, and it gives us the midpoint. Now let's say instead you are trying to find the other endpoint. So I'm gonna use the exact same values that we had before so you can see the power of this program. We'll go to endpoint, which is number 2 here. Here order matters. I have to input the midpoint first. So notice in this previous program, we found the midpoint was -2, -0.5. Let's say that's what we already know is -2, -0.5 for the midpoint, and we know one of the endpoints. So let's say we know -6, so we'll type that one in. And if we're trying to find the other endpoint, it does it for us. So pretty neat. So on to the final side and program number 15. So this program is called prime factorization. So we can get to the p's by pressing alpha and 8, and then we'll press enter. And then what this program does is finds the prime factorization of a number. So I'm going to type in 810, and it's going to determine that all the prime factors that it's composed of are 2, and then 4 3s, in other words, 3 to the 4th, and 5. So prime factors are numbers whose only factors are 1 in itself. The smallest prime number and the only even one is 2, and then we have 3, 5, 7, 11, etc. So this gave us the prime factorization, and if you were to multiply all these, you would get 810. On to program number 16. So to get to the p's, we said we could press alpha and then go over to 8, and then because this is the second p program, we'd press down and enter. And this program, again, is one of those that has multiple features to it. If we have both of which are only for when you have a right triangle. So Pythag is used specifically when you are trying to incorporate Pythagorean theorem. So if you have a right triangle, and we know a squared plus b squared equals c squared, right? But if we're trying to find a leg, we choose this first option. In other words, we know one leg, and we know the hypotenuse. So their order matters. We have to make sure we input the hypotenuse here, where it says hypot, and that's the leg that is the longest. It's the slanted one, it's the one across from the right angle, it's the one not touching the right angle, however you want to think of it. So we'll go ahead and input that as 13. And then it gives us the other leg as a radical as well as an exact value. Now, if instead I'm trying to find the hypotenuse, so let's say I know the two legs, I'll input those in either order, and then I get the hypotenuse value. On to program number 17. So we're at the point where once you're at the R's, you're pretty much at the bottom of the list. So I could wrap around by pressing up and then going up a few to radians. This is a really good program, another one that has multiple programs within it. If I have the radian measure and I'm trying to convert it to degrees, I'm going to choose this first option. And we're going to go ahead and type it in exactly the way that we see it. So let's say 2 pi over 3. You wouldn't necessarily want to use the fraction feature of alpha y equals, because in a program, it doesn't really work. It just makes it still a slash. So we'll just type in 2, and then to activate pi, you have to press second, and then the caret key, so notice the pi is in blue there. We'll do over, so divided by 3. When we press enter, it gives us the degree measure, so 120. That's the equivalent. Now, if we press enter again, just to get back to the program, if instead you wanted to go from degrees to radians, we'll choose the second option. And so if we had 120 degrees, we press enter, and it gives it to us as a decimal, carried out quite a bit, and then also the exact value. Notice the pi is over here, so it's 2 pi over 3. Program number 18. So we'll wrap around to get to radical, and what this does is it provides the simplest radical form for a value. So if I have root 108, I just type in the 108, and it's going to say that that simplified form is 6 root 3. Program number 19, sector. So this program helps us find the area of a sector. It's pretty similar to the program arc length. We're actually going to use the same values as before. So if we know the radius and the measure of the sector in degrees, it'll find the area of that sector. And notice it says times pi, so this is 25 pi over 12. So now we're down to our final 4 programs, all of which are just informational, not functional. So let's start out with program number 20. So this program is called shapes. We didn't really have a very creative name for it, but it essentially gives us either the area, volume, or surface area formulas for various shapes. So let's say we have various areas listed there, volume and surface area. On to program number 21. So this program is called SpecTri. It's short for special triangles. So there's two special right triangles. And let's break this down a little bit. So if you have a 30, 60, 90 triangle, what they're saying here is across from the 30-degree angle, you would label it X, across from the 60, X root 3, and across from the 90, 2X. So if X were 1, then this would just be 1, 2, root 3. If X were 5, this would be 5, 10, 5 root 3, etc. Now, if instead you have a 45, 45, 90, that ends up creating a isosceles right triangle. And they're saying across from both 45s is X, and across from the 90 is X root 2. So it could be 1, 1, root 2, could be 10, 10, 10 root 2, etc. On to program number 22. This program, Stats, gives us various pieces of information regarding statistics. Let's go ahead and take a look. It just tells us that mean is the average, median is the middle value, mode most often, and range is biggest minus smallest. So just reminds you of those things. On to our final program, program number 23. So trig is going to give us SOHCAHTOA as an acronym and lay it out for us of what sine represents, cosine, and tangent. You did it. You made it through the entire video, so I congratulate you. Obviously, that's a lot of information. You're going to want to be very familiar with everything that's on here, because if you don't know how and when to use each program, it's going to be difficult to really use it to your advantage. So come back here and check out anything that you need if ever you forget how to utilize any of the programs. And remember, you got this.